Hello everyone, welcome back to another MCR3U video, and in this video we will be covering the last section of chapter 6 on sinusoidal functions, which is section 6.7 on solving problems using sinusoidal models. Here's the chapter outline one last time, and the pages where you can find extra practice questions on today's topics is pages 398 to 401. Here's the success criteria for this lesson. We want to solve problems related to real-world applications of sinusoidal functions, and we want to take data from real-life examples and sketch a sinusoidal graph, right? So we want to take applications, make functions, and take those examples and sketch the graphs. Let's get right into the first example. This video is just going to be examples because we are just going over some real-life applications to sinusoidal functions. So this first one says a group of students is tracking a friend, John, who is riding a Ferris wheel. They know that John reaches a maximum height of 11 meters at 10 seconds, which is this point that we can see right here, and reaches a minimum height of 1 meter at 55 seconds, which is right here. Find the equation to model John's movement. Okay, so we have to find an equation in terms of cosine or sine to model John's height from the ground with respect to time. So our independent variable is obviously going to be height, and our time, and our dependent variable is going to be height. So we want to use cosine or sine. And for this particular example, I want to use cosine because, again, if you remember, the cosine graphs start at the max point at x equals 0. And this graph has a point right here very close to x equals 0, right? If we wanted to start with sine, we'd have to use a point around here and do the phase shift to that. But we'll use cos. So the cosine function is going to look like this. F of x equals a times cosine k times x minus d plus c. So we want to find all our missing variables and plug them in. How do we do that? Well, we do the same as we did the past few videos. We want to find the amplitude to find a. We want to find the equation of the axis to find c. We want to see what the phase shift is from looking at the graph, and we want to find the period to find k. Okay, so let's start with the amplitude. Let's start with the equation of axis, actually. Which is going to be, as we know, equation of axis, it's going to be max plus minimum all over 2. So we want to get to that midpoint between the max and the minimum. So the max is going to be 11. As in the question says, he's at 11 meters of max height of 11 meters at 10 seconds, plus the minimum height, which is 1 meter from the ground, all over 2. So we're going to have 11 plus 1, 12, divided by 2 equals 6 meters. Therefore, our C is going to equal 6. Okay, now that that's out of the way, we found C. Now let's try to find A, and let's draw in our equation of axis first so we know where it is. Y equals 6. Okay, next we can find the amplitude. So our amplitude is going to be half the distance between the max and midpoints, or half the distance, and going from the equation of the axis to a trough or to a peak. So let's just calculate it using our equation of max minus min all over 2, which is going to equal, the max is 11 minus 1 over 2. So our amplitude is going to be equal to 11 minus 1, which is 10, divided by 2 is 5. So our A value is just going to be 5. Now our K value, we want to find the period. And the period, we just want to draw one cycle of our equation, of our graph. So we can see that there is one cycle of our graph right here. From point to point, from max to max, that's one cycle. So how far does that cycle span in time? Well, we're going from 10 seconds all the way to 100 seconds. So what is the time between this, 100 minus 10, which is going to give us 90 seconds. That's going to be our period. Our period is going to be 90 seconds, as we know, period equals 360 over absolute value of k. So our period of 90 is going to equal 360 over k. If we do 360 divided by each side, we get 360 over 90 equals k. So k is going to equal 4. And now for the phase shift, for D, we want to look at what phase shift has the original cosine graph had, what phase shift it has had for it to end up in this position with the graph we're given. So let's just check off first that we have gone A and K, and now we just need D. So the original graph, again, the original cosine graph starts at a maximum at x equals 0, and it goes like this, and it goes like this. Okay, so if we apply a phase shift, this max is going to move somewhere from the middle. The graph is going to shift left or right. So we have to find a max in the graph and use that to analyze how much the graph has shifted. So the point that I said that we would use is this one. Because it is a max, as they say in the question, a maximum height at 11. So we want to use this point and see how far it is from the origin, right? And that will tell us how much the original y equals cos of x graph has actually shifted. So if we take a look at the independent variable time, we can see that from the x equals 0 to this point, there is 10 seconds. So our phase shift is going to be d equals 10. So if you apply a phase shift of 10 to the original cosine graph, you get to this position with this graph. So our final equation, because we have found our last variable, is a, which is 5, cosine of k, which is 4, times x minus 10, and our c value, which is 6. And that will be our final answer. And that is the equation that models John's movement on the Ferris wheel. Next example is just a follow-up from the last example. It says, what is John's height above the ground after 78 seconds? So we just want to use the equation we just wrote down, which was f of x equals 5 cosine of k was 4, x minus 10 plus 6. All we want to do in this example is plug in the time of 78 seconds into our independent variable so we can get our dependent variable and see the height of John at 78 seconds, which is about here. So we should get a number around 6, 7, 8, or somewhere there. So if we plug in our 78 into our function, we get 5 times cosine of 4 times 78 minus 10 plus 6. And so f of 78 will be 78 minus 10 times 4. Take the cosine of that, multiply by 5, add 6. We get about 6.17 meters. Therefore, John's, oh, that's not how you spell it. John's height above the ground after 78 seconds is 6.17 meters. And it makes sense because, again, we are in this range. If we look at the graph, we are in this range of between 6 and 7. Moving on to the next example, it says a paintball is shot at a wheel of radius 40 centimeters. The paintball leaves a circular mark 10 centimeters from the outer edge of the wheel. As the wheel rolls, the mark moves in a circular motion. Determine the sinusoidal function that models the mark's motion. Okay, so we have a wheel with a radius of 40 centimeters, so from the center to the outer edge, and the paintball is shot 10 centimeters from the bottom, this place right here, which also means that the mark is 30 centimeters from the middle of the circle, because if the radius is 40 meters, this distance is 40 centimeters, sorry, not meters. And so if it's shot 10 centimeters above the outer edge, then it's 30 centimeters from the middle. Okay, so we know that information. And what we want to find is all the same information we found in the last question, but now we just don't have a graph and we have to kind of think about it, right? So first we want to find the, we're going to model this using, let's say you can use sine or cosine. So we want to write our equation, let's say in terms of cosine. So we'll do f of x equals a cosine of k times x minus d plus c. In this case, x, it's going to be the distance the wheel rolls. So distance rolled, and f of x will be height of mark above ground, right? Those are our variables, and that's the equation we want to find. So what is our graph kind of going to look like? We'll sketch it here on the side, or on the bottom. We're starting at the minimum point because the mark starts here at its lowest point, and if the wheel rolls this way, the mark is kind of going to go outwards like this. It's gonna go this way. So we're starting at the bottom, and the mark will go up to the top. So if the bottom is here, then we know we're going to go up, then we're going to get to some max, and we're going to go down. Then this is going to be the bottom again. Oh, the bottom is at 10 centimeters, not right at the origin. So the graph's going to look something like this, and then up, and then back down, and then up, and then back down, and then up. And we have a maximum height here that we can calculate for. If the paintball, say it's up here, how far is that from the ground? Well, if the height from the mark here to the middle is 30 centimeters, that means this distance is 30 centimeters, right? And if we add the distance from the ground to this mark, that distance is going to be this 40 centimeters plus this 30 centimeters, which is going to give us 70 centimeters. So its max height is going to be 70 centimeters off the ground. Okay? So now we kind of have a rough sketch of the sinusoidal graph. We have a max and a min point. That means we can find the amplitude, which is going to give us A. We can find we can find C, which is going to give us, we can find the equation of the axis, which is going to give us C. Then we need to find the period to find K, and then we need to find the phase shift of the graph. So let's begin by finding the easy stuff. We'll find the amplitude, which will be the max minus the minimum. So that's the distance between them divided by 2. So A will actually be 60 divided by 2, which is 30. That will be our A. Okay, then we want to find C, which is the equation of axis, which is going to be the max plus the min divided by 2 to get right in the middle. 70 plus 10 is going to be 80 divided by 2 is 40, which means that C equals 40. Okay, so we have found two pieces of our equation. Now let's keep going. Now, to find the period, we need to find the measurements for the independent variable, x. And that's going to be the distance the wheel rolls. Now, the distance the wheel rolls can be calculated using the circumference of the wheel, because the distance the wheel rolls is the distance that the side of the wheel rolls, right? So if we can calculate the circumference of the circle, we can actually calculate every quarter of the circumference or every half of the circumference that the wheel rolls. The mark will go from the bottom to the top, from the bottom to the top. So we can calculate the circumference using C equals 2 pi r, r being the radius, and we know the radius is 40 centimeters. So our circumference is going to be 80 pi centimeters. Okay, we'll leave it at pi to get a nice number there. Now, this is the whole circumference of the entire circle. But we want to find the period, and this is actually period. The period will be the whole circumference of the circle, because one roll of the wheel means this mark will go all the way to the top and then all the way back to the bottom. And the distance covered by the wheel will be the circumference of the wheel, because it does one rotation, right? So this is actually going to be our period. Our period will be 80 pi. So now we can find k, because 80 pi is going to be equal to 360 divided by k, right? So if we do 360 divided by each side, we get k equals 360 over 80 pi, which is going to give us, it's going to give us 4.5 over pi. So we'll put that into decimals. We'll work in decimals now. It's going to give us about 1.43, or we'll actually keep it with pi, so it looks nicer. So this is actually just going to be 9 over 2 pi. Okay, 360 over 80 pi is going to simplify to 9 over 2 pi. So that's our k value. Okay, now the last thing we have to find is the phase shift. Now the phase shift will be the amount of distance that the wheel covers when this mark gets right to the top. Because if we're using cosine, as we are, right, we want to find the phase shift to this point on the graph, from here to here, because that means our original cosine of x graph will have shifted that much to the right. Or something better that we could do is actually not have a phase shift, but have a reflection. Yes, I think we'll go for that, because we have a minimum. We're starting at a minimum at x equals 0. And so if we can flip the graph, that means our original cosine graph will have been like this. Not exactly here, because the cosine graph starts down here, but with all the transformations except the reflection, the cosine graph starts here, right? But if we make a reflection, then it becomes this red graph down here. So we can say that the original cosine of x graph has been reflected along the x-axis, which will give us this flipped version of the cosine graph, right? So if we're instead of starting at the max point, this graph that we have starts at the minimum point. So that means there has been a reflection along the x-axis of the cosine graph. So all we want to do is make our a value negative, which will give us a reflection along the x-axis. So therefore, we have our equation, which will be negative of the a value, cosine of our k value, which is 9 over 2 pi, times x, because now we don't have a phase shift, plus 40. And that equation will model the movement of the wheel, the height of the mark with respect to the distance the wheel covers. And last example here, we want to determine the height of the mark after the wheel travels 120 centimeters. Okay, so if we bring back our equation, we'll have negative 30 cosine of 9 over 2 pi x plus, it was 40? No. So it was 40. This is 40, and this is our equation. So again, just like in the last example, to determine the height of the mark, which is our dependent variable, we want to plug in our independent variable, which is when the wheel travels 120 centimeters. So f of 120 will be negative 30 cosine of 9 over 2 pi 120 plus 40. That will give us 9 divided by 2 pi times 120 cosine of that times negative 30 plus 40 will give us about 69.7 centimeters. So we're pretty much at the maximum height, because remember, the maximum height is 10 centimeters plus 30 centimeters plus 30 centimeters, which is 70 centimeters. So we're basically at the maximum height at 120 centimeters right there. And that is it for the video, guys, and that is it for chapter 6. I hope you guys were able to understand sinusoidal functions well, and were able to keep doing the textbooks questions after each and every lesson. If not, it's okay, but make sure you keep practicing, and if you don't understand concept fully, go back to the videos or do some more examples so you can really understand it.